Integers and the coordinate grid. So this standard that we're going to learn about today is find the position integers and other rational numbers on a horizontal line, vertical number line diagram. Find and position pairs and integers and other rational numbers on a coordinate plane. Hello, sir. Thank you. So we're going to be drawing polygons on a plane given coordinates for the vertices. I'll tell you guys what those all are. Use coordinates to find the length of the side joining points in the same coordinate and the same second coordinate. Apply these techniques in context in solving real-world mathematical problems. So this is what we're going to be able to do. You're going to be able to locate and plot on a coordinate plane. So you're going to locate and plot on a coordinate plane. You spell coordinate plane like this. Coordinate plane. Oh, actually it's, yeah, coordinate grid. All right, using a vertical number line, so this is the do now. This is going to be on your, let's see here, 2, 5. Make sure that this, we're going to do this on the, No, we're going to use a vertical number line. Here's what we're going to do. I want you to draw one rather than do it. We're just going to do it right on the note sheet. You didn't get a second sheet? Okay, that's fine. We don't need it right now. So on a vertical number line, so that's going to be a number line. So we're going to draw this in on our notes, people. On a vertical number line, so there's our number line, but it's going to be vertical. I want you to go, so this will be 0. I want you to go 1, 2, 3, 4. 1, 2, 3, 4. This will be -4. This will be 4. No, on the right, to the right of your. Actually, you can go to the left. I guess you could say where it says underneath the coordinate plane in your notes. So going to the left, where there's that open section by the hole punch. You're going to plot the following numbers on the number line: -2. 5, 1/2, 0, -3, and 1/2. So this is just like what we did last week, but it's on a vertical line. And then it says assign a letter to represent the location of each number. So plot those 6 numbers. Just like what we did last week. So I see no, okay, finally I see 2. So you got that information right? Yeah. Well, you didn't plot those numbers yet. None of those numbers are on there. There's 0. Oh. Yes, as I said 4 times already, plot those. Same things we did last week, just now they're going to be vertical. Yes. Make another one. Mm-hmm. Mm-hmm. Hey. Thanks. Yes. That's 1/2. That's 1/2. That's just a layout issue. Oh, yeah, there isn't a comma there, so I see what your question is. Yeah, it's -3.5. I didn't see that there was missing a comma. Mm-hmm. So here's what you should all be having. I have a seat right here. So you should have, we have -2, so it's 1, 2 right here, and I'm just going to call that A. Then there's going to be 5, which is going to be up here. I'm going to call that B. Then there's going to be 1/2, which is going to be right here. I'm going to call that C. And then we have 0. Call that D. Then -3.5. So it's going to be 0, 1, 2, 3.5. E as in elephant. That's what yours should look like. Any questions on that? It's just the same exact stuff we've been doing. It's just standing up as far as the number lines we're going to be doing. Coordinate plane. A coordinate plane, or a Cartesian plane, is formed by two number lines that intersect at right angles. The horizontal number line is the x-axis. The x-axis goes like, whoops. The x-axis is right here. This is the x-axis. It goes left and right. That's always the one that's said first and shown first. Okay? That's the x-axis. And you see how we've got an x right here? Okay? That's showing us that's the x-axis. Okay. And the vertical number line is the y-axis. So y is right here, and it's indicated right there as having a y in italics. The two axes divide the plane into 4 quadrants. Now, when you're looking at the quadrants, it's shown in a clockwise manner. So as if this were 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, the first 3 hours of the day are right here, and that's why that's quadrant 1. So it's clockwise. So we have quadrant 1 here, quadrant, I said that backwards. It's in a counterclockwise way. It's quadrant 2 here, quadrant 3 here, and quadrant 4 here. Okay, see how those are numbered in Roman numerals? Okay. So as we're in quadrant 1, then it's quadrant 2, then it's quadrant 3, quadrant 4. Now, we're not going to be moving really in this direction, but that's the way that they're just counted. Okay, after quadrant 4, it starts over again at quadrant 1. There we go. I forgot to talk about the origin. All points on a plane can be named using coordinates. Okay, have anybody ever heard that in a movie or anything like that, your coordinates? Okay, what were they talking about in that, Quinn? Exactly. Where they were. Great way to put it. Do you have anything else to add to that? Yep, exactly. Longitude and latitude. That's exactly what we're doing. What's going on down there? Let's go. Yeah. Trying to find your destination. Beautiful. So location, geographical location, and destination. Beautiful, because it's always showing where something is located. Well done, well done. And the ordered pairs are written in the form x, comma, y. So the first number is the x-coordinate, so that's where it shows on the x-coordinate, the way that we are just doing it, or at least from left to right where it is. So if we were doing the location of something and it had the x-coordinate, it would be bouncing this many times on the x-coordinate, one direction or the other. Okay? And then from there, the point it would be the second number is the y-coordinate. So if we were going to 3, 4, it would be 3 this way, and then 1, 2, 3, 4 right here. So this is the spot that we would find ourselves if we were at 3, 4. See how that is? Bouncing 3, 1, 2, 3, and then 4, 1, 2, 3, 4, and we end up there. Lauren has a puzzle for Olivia. What goes up a chimney What goes up a chimney down, but can't go down a chimney up? So, when Olivia finds the answer by plotting and connecting these points in order on a coordinate plane, what is the answer? So this is what we're going to do. We're going to do this together. I'm going to show you how to get started, and then I'm going to get you going with the rest of it. Okay? So here is our coordinate plane, and you do have this. Okay. What? This is, well, yeah. No, we're going to use, no, we're still on our notes, guys. It's right here, right where it says exactly what Olivia, Lauren has a puzzle for Olivia. We're not bouncing around. Okay, so we're starting, and it asked us to do, so we're starting at negative 5, 1. Come on. There we go. So we're starting at negative 5, 1. So that means, negative 5, negative 1. So that means that I'm going to go 1, 2, 3, 4, 5, and then here to that negative 1. Okay, because the first number is the x, so we move up and down the x-axis. The second number, we move down the y-axis. So negative 5, negative 1. Please mark negative 5, negative 1. Yeah. Then the next number we have is negative 4, positive 1. So I go negative 4 this way, and then positive 1 up. Negative 4, positive 1. And see how we're starting at the origin every time? 0, 0. This is the origin right here. It's the number in the middle. That is what the origin is. 0, 0. That's always where you start. Yes?
So it's kind of like the starting point to race.
Exactly. Yep. Or the origin of anything. Like where something starts. Origin is where something starts. Whether it is the origin of a huge billion-dollar company, you know, the origin where that company started, an idea or something like that. So then we have, the next one is negative 2, 3. Negative 2, 3. So we go to negative 2, over here, negative 2, and then positive 3. 1, 2, 3. Oh, and we're also supposed to be connecting these. Yeah. All right, I want you all to continue with that. If you get stuck, you can look up and see where I'm going with it. Make sure you're doing them in order and connecting them in order. The next one, negative 2, 3, then 3, sorry, positive 2, 3. Positive 2, 3. I'm going positive 2 and then up 3. Then we have 4, 1. 1, 2, 3, 4, and up 1 right here. I need to turn off that noise later. Then we have 5, negative 1. 1, 2, 3, 4, 5, negative 1. Yep, if it goes 4, 0, that means it's going to be on the 0 of the y-axis. Where the intersection happens, that's the origin. That's 0, 0. Where does what? 0. Whenever you see 0 on something, that means it's going to be on the black line. It's going to be on the axis, or on the axis for you St. Louisan accent people. 5, negative 1. 4, 0. Let's see, you're missing the... Yeah, we shouldn't have gone... You're at negative 1, 1 here. There's no negative 1, 1 here. Yep. Yeah, that's negative 1, 1. Do the counting. Put your pencil on each bounce as you do it. So that's negative 1, 4, 0, 3, 1, 3, 1, 2, 3, and 1. Two, 0. 1, negative 1. 0, 0. Negative 1, 1. Negative 2, 0. Negative 3, negative 1. Negative 4, 0. Negative 5, negative 1. Then it has to start a new one at 0, 0. Then go to 4, 0, negative 4. Negative 1, negative 5, negative 1, 1, 2, 3, 4, 5. Negative 2, negative 5, 1, 2, 1, 2, 3, 4, 5. Negative 3, negative 4, 1, 2, 1, 2, 3, 4. Maybe. Don't look. Don't look. Something's telling me that this is not right. Because this spot here. So if those of you that are done, take a look up here. Now something tells me that one of these might not be looking right. Now if this is this one here, okay, I'm going to double check and see, well, what quadrant is that one on? What are it's in quadrant 1, sorry, but what are the coordinates of that dot? Maddie, do you know? 3, 1. So let's see if I have a 3, 1 after a 4, 0. So is there one that goes 4, 0 and then 3, 1? Ah, 3, negative 1. Yep, we found it. We found it. There we go. Mm-hmm.
Because if this is negative 1, then when you come down to here, so then you would go over the negative.
If it's a...
Go over the negative. Here it's negative 1.
Where?
So that one.
Negative 5, negative 1.
No, negative 5, negative 1.
Yeah, that is... You go bounce this many. Let's do it here. We will be. We will be. So... What you would do is you bounce for negative 5, negative 1. You bounce 1, 2, 3, 4, 5 on the x-axis. Then you go down on the y-axis 1, negative 1, right here. Does that make sense? Or if we wanted to do 8, Let's do 8 and negative 6. I would go 1, 2, 3, 4, 5, 6, 7, 8. From this point here, I'm going to go 1, 2, 3, 4, 5, 6 to get down to negative 6. Cool? Now, if you were to say what the coordinate plane was on your notes, as it says to do the quadrant, axis, and origin, what that means is you're going to write down whether it's going to be in quadrant 1, 2, 3, or 4. So you just do 1, 2, 3, or 4, or you would do the axis. That means if it's on one of the lines. So if it was one of them that was on the line for the 1, 2, 3, 4, 5 that you had on there, you would just put if it's on the y-axis or the x-axis. Yes, sir. Mm-hmm. We just did that together, brother. Okay, you did 4, 1 rather than 4, negative 1. Or yeah, this one here. You did 3, 1 rather than 3, negative 1. Okay. So what you would have is you would say whether it's on the x-axis, the y-axis, the quadrant on that one. That's how that would work. But I want to get moving along. What do you notice? On the back side of your notes, I would like you to write or graph those points. So it's really, really not easy to see that. But you can shade those in a little bit. You can shade those in a little bit. See how it's very, very lightly. You can see the coordinate plane. Just 3L. So it says we're graphing the points 3, 2, 3, negative 2, and negative 3, 2. So it's 3, 2. So I'm going to go 1, 2, 3, and then 2 up. 1, 2. Yes. Yes. I'm going to go keep it red. I'll go blue. So that one is 3, 2, then we have 3, negative 2. Then we have negative 3, 2. 1, 2, 3, oops, negative 2. What do you notice about these? How are they different from one another? Yeah, City? Exactly. They're each in a different quadrant. Can you tell me which quadrant does not have one inside of it? Chloe. The second quadrant does not. The second quadrant does not have one. So then think about this. What do you notice about 3, 2 and 3, negative 2? So we're looking at these two. This one and this one. What do you notice about those two with respect, or in relation to the y-axis? In relation to the y-axis. What do you notice about it? Skylar, what do you think? They're both on the right side of the y-axis, because if you recall, this is the y-axis, this is the x-axis. Good. Okay, they're both on the right side of it. Good. Maddie? One of the two of them is negative. True, because it's on the y. It's on the y-axis. It is. This one is 2 up. That one's 2 down. Yeah.
If you took
Yeah.
One's negative and one's positive.
Yeah, tessellations, reflections. Yep, we'll get into that in the future, for sure. Avery?
The last one, it would be the third quadrant that would be open because negative 3, 2, you would go right over and you would go up.
Oh,
The y-axis.
my. Yeah, I need to make these bigger. These tiny, tiny things. Good catch. Thank you. Yeah, it's not bigger. Because we're looking at, to get over to that spot, because the third one's actually negative 3, 2. So it's going to be 1, 2, 3, 1, 2. And then there's my, yeah. Good catch. Two smalls of negative signs. Okay, then how about how they relate to the x-axis? How about how they relate to the x-axis? Similar situation. They're like a reflection of each other. Yep. Like a reflection of each other. Consider this. A is at negative 5, 3, and B is negative 5, 1. What is the same about points A and B, and what is different? So go ahead and put that onto the coordinate plane that you just had. Label them A and B, negative 5, 3, and negative 5, 1. Yes? Negative 5, 10. Is it different?
Yeah, it is.
Interesting. Yeah. Okay, do what it says in your notes, because this, in the notes, I guess it says, this here is 10. So the first one, second one, rats. So let's just go to this one. Number 2, is this a vertical or horizontal line if you connected them? Vertical. Yep. If you have it vertical, you did it right. And then what is the length of that line segment? How many integers does that line segment go? Yeah.
7.
It's 7 because it's 10 minus 3, which is 7. Beautiful. We are. Let's see here. We'll get to that. I think pretty sure. I want to get to that, but I want to explain the homework. So that's the end of that for this. Adios.